So to convert units, you first look at the base unit. So you want to convert whatever unit you're given into the base unit to make all conversions easier. So then you don't have to go between different conversions and try to figure out the powers of 10. Then you want to list out all the conversion factors that are possible for this problem, and then you would use dimensional analysis to solve. So let's give a brief overview. So say you want to convert nanometers to centimeters. So first, you would convert nanometers to meters, then to centimeters. Then you'd write down all the conversion factors. So from nanometers to meters, 1 meter equals 10 to the 9th nanometers, and 1 meter equals 10 to the 30 centimeters. The third step would be to use dimensional analysis to convert from nanometers to meters, then to centimeters. Now, if they give you a unit that is squared, such as nanometers squared, and you want to convert that to, let's say, centimeters squared, you'd have to apply this property twice, or however many powers there are in order to get the right answer, because there's a multiple of 2, in this case, nanometers, so you'd have to apply the property twice here. So let's do an example. So say you want to convert 3.1 times 10 to the 5th meters per second squared into nanometers per millisecond squared. Okay, then what you would do is, 1, it's already in the base unit, which is meters per second, so you don't have to do that. So the first step is done. Now, for number 2, you want to list out the conversion factors. So 1 meter equals, for nanometers, it's 10 to the 9th nanometers. Then, for the denominator, here we have seconds, and we want to convert that to milliseconds. So we'd write 1 second equals 10. Oh, this should be, that's 10 squared centimeters, my bad. But 1 second should be 10 to the 3 milliseconds. Now, the third step is to use dimensional analysis. So we have 3.1 times 10 to the power of 5 meters per second squared. Then we convert that to, so we had meters to nanometers, and we had seconds to milliseconds on the bottom, or squared, I should say. So that's not squared, but then you want to convert the numerator, you do 10 to the 9th nanometers on top, because you want the meters to cancel out. So this would cancel this out. And then you'd multiply 10 to the 3rd milliseconds per 1 second, since you want the seconds. That should be the other way around, actually. You'd multiply 1 second by 10 to the 30 milliseconds. Then you'd multiply it again by 10 to the cube milliseconds, so the seconds would cancel out with the seconds squared, and you're left with meters per second squared. So then you end up getting 3.1 times 10 to the power of 8 nanometers per millisecond squared, and you're done.